Okay, so here we go with the free response part of this Unit 4. Oh, I don't want to start with 13. I want to start with 11. Here we go. So I'm going to make a box. I'm going to make a thousands table. So we can start with a thousands table, or we can start with whichever you'd like. So I'm going to do 1,000. So I'm going to look at, let's see, studied, not studied. So I have studied, I have not studied, and I have total. I have passed, didn't pass, and total. So here's my 1,000. So what percent studied? 70% studied. So this number right here is 700, and this number right here is 300. Of those who study, this group, 95% passed. So I have to find 95% of this number. So I multiply 700 times 0.95, and that's 665. So that number goes right here, 665. Okay. And then that means that this number is what, 35? Yeah, thank you. Of those who did not study for the test, 60% pass. Okay, did not study is 300. 60% of this group, which 6 times 3 is 18. So this right here is 180. And that makes this right here 120. This total doesn't matter because our probability that a teenager who passes the written test did not study. Okay, so we want did not study and yet passed. So our given is that they passed the exam. So did not study, prime. We add these two together to get this total. That's what we're looking for, the total number of passed. So that's, there's a 5 there, 8 and 6 make a 4 there. Excuse me, carry a 1, that makes that 845. So this ends up being did not pass out of the total. So that's 180 out of 845. And that's approximately 2.13. So about 21%. Okay, now if you did a tree diagram, you would do the same thing. You would do studied, not studied. So this would be study. And let's see, this would be 0.7, this would be 0.3, and then you would do passed, not passed. This would be 0.95, this would be 0.05. And these two numbers here, this would be 0.6 and this would be 0.4. And then you could find these numbers multiplying straight out. Find the pass, which would be this number plus this number, add them together and divide by this total. This is 0.18, obviously. Okay, this is 0.665. Find the sum of these two, which is 845, and divide by, divided into 0.18. Right, here down here on this one, you believe there is a 20% chance you will earn an A in the English class, a 10% you'll earn an A in physics, and a 5% that you'll earn an A in both. So again, I'm going to make another table just because I'm comfortable with that. So here's my 1,000. Okay, and this is going to be my total, and this is my total. And so we have I made an A in English, I didn't make an A in English. I made an A in physics, I did make an A in physics. Okay, so our numbers here, 20% you'll earn an A in English. So this is 200. So most of y'all like me, that 80% that didn't. Physics is 10%. So that's 100. There's 900, like me, that didn't make an A in physics. And a 5% that you earn an A in both, right here. Bingo, bango, that's 50. So that makes that 150. That makes this 50. And let's see, this number right here, I think is 750. Not that it matters. Okay, find the probability you did not get an A in either English or physics. Didn't get an A in either one. Probability of not an A in English or not an A in physics, so you didn't get it in both, is this answer right here. So that's 75%, 0.75. Neither of them. I'm going to write and right there. You didn't get an A in both. That should be and. Are earning an A in English and earning an A in physics disjoint? Disjoint means they did not occur at the same time. No, because 5% got an A in both. They're not disjoint because 5% of the students got an A in both. Okay, are they independent? Well, the first thing we can look at is this. If I take 0.2 times 0.1, and if that equals this number, then they are. So here we go. So I'm going to go 0.20 times 0.10. That equals 0.02. That's not 5%. That doesn't equal 5% from the table above, or 0.05. So no, they're not. Or we can do this. Let's look at the probability of making an A in English is 0.2. Then we find the probability. Sorry, I'm not showing everything. Then we find this was what we did at first. We took from the table here, these two multiplied together. If they equal this, then it will. But this times this does not give me that, as I show here. They're not independent. Or we can do the probability of English is 0.2. Find the probability of you made an A in English given that you made an A in physics. Okay. English, given that you made an A in physics. Agreed? Everybody see that? I'm going to look at the probability of this. I made an A in English, given that also, so I'm looking at this row. So that's 50 over 100. That's 0.5. These two are not equal. Okay, we could also find the probability that you made an A in physics and then compare that, the probability you made an A in physics, and then compare that to the probability that you also got an A in English, and those numbers also do not work out to be the same thing. Okay, so these are not equal, these are not independent. They're not independent. All right, so let's look over here at this side. Heights of adults. Men, women. Standard deviation. How much taller are men than women on average? Okay, so I'm going to go 69.1 inches minus 64 inches equals 5.1 inches. Men are, on average, 5.1 inches taller. Standard deviation. Square, add square root. So the square root of 2.8 squared plus 2.5 squared, we never add, we never subtract. Standard deviations. We find the variances and we add 2.8 squared plus 2.5 squared equals, so the second square root of 14.09 is 3.75 inches. It's my standard deviation. Okay, assume that women date men without considering the height of the man, that the heights of the couples are independent. What is the probability that a woman dates a man shorter than she is? Okay, we did this the other day. I've got a standard deviation. I've got a mean. So let's make a normal model. Drop this down. This is 5.1. So 5.1 minus 3.75. It's 1.35. Minus 3.75, negative 2.4. So this is where, somewhere in here is where women and men is 0. So we're looking for this area. So it's a normal model. So I'm going to say normal CDF. Whoops, I didn't mean to put an equal sign there. So second distribution, normal CDF. Okay, so my lower here is going to be negative 100. This is my lower value, comma. My upper value is going to be 0. My mean is 5.1. And my standard deviation is, what was it, 3.75. Sorry, I ran out of space there. That's my standard deviation. Okay, so on my calculator, got a negative 100. I don't think there'll ever be that much difference. 0, 5.1, 3.75, paste. About 8.087 is what I'm going to say. 0.087. So about 8.7% of the time women are taller than men. Okay, so here we go on the last one. Luxury cars, according to info, please, 18% were silver. They sell 50 luxury cars a month. So here we go. So P is 0.188. Makes Q 1 minus 0.188, 0.812. Okay, explain why they consider Bernoulli trials. Okay, so success, failure. Either the luxury car is silver or it's not. Each one is independent. Each cell is independent. Independent, sorry. And third but not least of anything, the probability remains constant. So 1, 2, and 3. These three things are Bernoulli trials. Okay, what is the probability the fifth luxury car is the first one silver? So this is geometric. So not, yep. So 0.188, 0.812, 0.812, 0.812, 0.812. Okay, so we go 0.812 raised to the fourth times 0.188, and we get about 8%. That's funny. It's approximately 0.082. And then last but not least, bottom of the card here, let X represent the number of silver cards sold in a typical month. What is the probability model? And find the mean and standard deviation. Okay, so we want to know how many sold in a typical month. So is that binomial or geometric? Okay, that is binomial. We have a fixed trial. So the mean and standard deviation. So the mean here is NP. They sell 50 cars in a month. Mu equals NP. So that's 50 times 0.118. About 5.9 silver cars or 6. Now standard deviation is the square root of NPQ. So that's going to be the square root of 50.118.812 times 0.12 square root 4 with a standard deviation of about 2.2. So I took 50 times 0.18 times 0.812 to get the 4.7908 and found the square root of it, gave me my standard deviation, the square root of NPQ. This is NP, which is 5.9 silver cars sold in a month. Let's put per month here. With a standard deviation of 2.2. Okay, I hope that helps. That was only